waiting to find the area. SQ High Maths 2018, paper 2, question 1, nice simple one here. The diagram shows this curve. Find the calculated shaded area. So it's the area between -1 and 3 of this minus the x-axis, so just this. So it's the integral between -1 and 3 of 3 plus 2x minus x squared dx. So that gives me 3x plus add 1 to the power, divide by the new power, minus add 1 to the power, divide by the new power, between -1 and 3. Tidying that up, 3x plus x squared minus x cubed over 3, between -1 and 3. You've got most of the marks so far, we just need to sub in our numbers now. So we get 3 times 3 plus 3 squared minus 3 cubed over 3. Take away 3 times -1 plus -1 squared minus -1 cubed over 3. 3 threes is 9. 3 threes is 9 again. 3 cubed is 27, divided by 3 is also 9. So our first bracket becomes this, minus our second bracket, minus 3, -1 squared is +1, -1 cubed is -1, times -1 is +1. So we get to here quite quick. 9 plus 9 minus 9 is just 9. Minus 3 plus 1 is -2. Plus a third, I'll take my time on this. So we get 9 minus 2 plus a third is -1 2/3. 9 plus 1 2/3 is 10 2/3, and we're done there. SQ High Maths 2018, paper 2, question 8 on the vector scalar product. U and V are defined as V's vectors. Find U dot V. Start of the exam paper tells you what U dot V is. You times each element and you add. So U dot V is equal to -1 times -7 plus 4 times 8 plus -3 times 5. That gives us 7 plus 32 minus 15. 7 plus 32 is 39. 39 minus 15 is 24. Okay, part B. Find the acute angle between U and V. So again, the start exam paper, A dot B is equal to the size of A plus the size of B times the cos of theta. So we know the size of, we know the A dot B, so we need to find the size of U and V. So the size of U is equal to the square root of -1 squared plus 4 squared plus -3 squared. -1 squared plus 4 squared plus -3 squared. That's the square root of 1 plus 16 plus 9. That is 26. And then the size of V is equal to the square root of -7 squared plus 8 squared plus 5 squared. (49) plus 64 plus 25. Use the calculator anytime you want. That's 138. So that means that U dot V is equal to, we know that's 24. So 24 equals square root of 26, square root of 138, cos theta. So rearranging for cos theta, that means that cos theta is 24 over the square root of 26 times the square root of 138. So our theta is the inverse cos of all that. So we just get a calculator and work it out. So the inverse cos, 24 over root 26 times root 138. That gives me an answer of 66.38. So theta equals 66.4 degrees. And we're done there. Increasing and decreasing functions, SQA Higher Maths 2018, paper 2, question 3. A function is defined as a set of real numbers given by f of x is x cubed minus 7x minus 6.
Determine whether f is increasing or decreasing when x equals to 2. So we need to work out the gradient of the tangent at x equals to 2. So f dash x is equal to 3x squared minus 7. At x equal to 2, f dash of 2 in other words, we get 3 times 2 squared minus 7. That's 3 times 4 is 12, take away 7 equals 5. And then we need to write a little statement. Since f dash of 2 is greater than 0, the function is increasing at x equal to 2. And we're done there.
SQA Higher Maths 2018, Paper 2, Question 4. Express minus 3x squared minus 6x plus 7 and ax plus b squared plus c. So completing the square on this. So we take our function and we take the common factor out, which is minus 3 of the first two terms. So that gives us minus 3. We've got x squared then plus 2x, because minus 3 times 2 is 6x, and then we've still got the plus 7 on the end. So completing the square on this bit, we get minus 3, half the term, so x plus 1 all squared, and take away 1 squared, 1 times 1. And then we've still got plus 7, so that gives me minus 3, x plus 1 squared minus 1 plus 7, and then expanding that bracket, that's minus 3x plus 1 squared. 3 times 1 is 3, it's minus times a minus, so it's plus 3 plus 7. And then finally, our final answer, minus 3x plus 1 squared plus 10. And we're done there.
SQA Higher Maths 2018, Paper 2, Question 5. PQR is a triangle with 3, 4 and Q9 minus 2 as shown. Find the equation of the perpendicular bisector of PQ. This is a circle question, but the circle part comes later. So this is straight line to start with. So we need the equation of a perpendicular bisector. So that cuts this in half. So we need the midpoint. Well, that equals 3 plus 9 divided by 2 and 4 plus minus 2 divided by 2. That's 12 over 2, which is 6, and that's 2 over 2, which is 1. So we've got our midpoint, and then we need the gradient of PQ because this is perpendicular. So the gradient of P and Q is minus 2 take away 4, y2 minus y1 over 9 take away 3, x2 minus x1. That's minus 6 over 6, which is minus 1. So therefore, the gradient of L1 equals 1 since m1 times m2 equals minus 1. So now we can use y minus b equals mx minus a. Y minus 1 is equal to 1x minus 6. Or y minus 1 equals x take away 6. So y equals x minus 5. And we're done there. Let's move on to part B. Part B of this question says L2, the perpendicular bisector of PR, the equation of that is 3y plus x is 25. Calculate the coordinates of C, the intersection between L1 and L2. So we're solving simultaneous equations because it's find the point of intersection between two lines. So our first equation is given to us, 3y plus x equals 25. And we just worked out, remember, that y equals x minus 5. Was the other equation. So rearranging that so that everything's on the same side, you've got y minus x equals minus 5. Adding these together, you get 4y equals 20, so y equals 5. Subbing it into this equation here, we get 5 equals x minus 5, so x must be 10. The point of intersection is 10, 5. Part C of 2018, Paper 2, Question 5. This is where the circles come in. C is the centre of the circle which passes through the vertices of triangle P, Q and R. So C is our centre, which we've just worked out, remember, is 10, 5. So we can note that on our diagram. And it says determine the equation of this circle. Remember, the equation of a circle from the start of the exam paper is x minus a squared plus y minus b squared equals r squared. And a and b is our centre. and obviously r is the radius. So now we just need to work out the radius then. So we need the distance between the centre and one of the points. So any one would do, but we'll know P, we know Q. So let's use P, let's work out this distance. I'll just draw it on for us. There's our radius there. So using our distance formula to get r equals the square root of x2 minus x1, so 10 minus 3 squared, plus y2 minus y1, 5 minus 4 squared. So that equals the square root of 7 squared plus 1 squared, which is the square root of 50. 7 7 is 49 plus 1 is 50. Now, we would simplify that normally, but we're going to square it back up anyway because we need r squared. So now it's very simple. The equation of our circle is just x minus 10 squared plus y minus 5 squared equals 50, r squared. And we're done there.
Okay, composite functions, SQA Higher Maths 2018, paper 2, question 6. F and G are given by 3 plus cos x, and G is 2x. X is a member of the real numbers. Find an expression for f of g of x and g of f of x. So part A, 1 f of g of x. That's f of, well, g of x is 2x. So every time I see a x in f of x, I write 2x instead. So that's 3 plus cos 2x. Nice and simple there. And for part 2, g of f of x. So every time I see g in it, I write f of x for x, and f of x is 3 plus cos x. So it's g of 3 plus cos x. G is 2x, so that's 2 times 3 plus cos x. And we can tidy that up a little bit by multiplying the bracket out to get 6 plus 2 cos x, and we're done there. Part B says determine the values for which f of g of x equals g of f of x. So just make them equal to each other. So for part B, we're saying that 3 plus cos 2x equals 6 plus 2 cos x. And we need to solve for x. Everything over at the same side to get cos 2x minus 2 cos x. And then we've got 6. 3 take away 6 is minus 3. That equals 0. So cos 2x we can expand using the start of the formula sheet. We're going to use the 2 cos squared x minus 1 form of it because we've all got causes for everything else. So that gives me 2 cos squared x minus 1. Take away 2 cos x. Take away 3 equals 0. Or 2 cos squared x minus 2 cos x minus 4 equals 0. So 2 is a common factor in this case, so I can just take 2 out as a common factor to get cos squared x minus cos x minus 2 equals 0, and we can then factorise it because it's a quadratic. So it's 2 double brackets. We get cos x and cos x in the first place, 2 and 1, and we've got minus 1 in the middle, so it's minus 2 plus 1, and therefore cos x equals minus 1, or cos x equals 2. So we've got two answers, but cos x equals 2 has no solution, so we can just write that straight away because the maximum and minimum value of cos is 1 and minus 1. So we just need to solve the other one. Cos x equals minus 1, so I can do the inverse cos of 1, which is 0 or 2 pi. But then our cast diagram, cos was negative, so it is pi minus and pi plus in these quadrants. X equals pi minus 0 or pi plus 0, which is pi, or pi minus 2 pi is out with our range, and pi plus 2 pi is clearly out with our range as well, between 0 and 2 pi. So it's just x equal to pi as our solution, and we're done there. This is the remainders. SQA High Maths 2018, paper 2, question 7. Part A show that x minus 2 is a factor, then factorise fully. Then part B is a sequence question. Sequence is not in the course this year, but I'll show part B anyway for the sake of completeness. Show that x minus 2 is a factor of 2x cubed minus 3x squared minus 3x plus 2. So we can set up our synthetic division. We've got 2 minus 3. We've got minus 3 and 2. And it was x minus 2 is a factor, so we can sub 2 in. So dropping the 2 down, 2 2s is 4, 4 minus 3 is 1, 2 1s is 2, 2 minus 3 is minus 1, 2 times minus 1 is minus 2, and we get 0. And therefore, since the remainder is 0, x minus 2 is a factor. And now we can try and factorise it. So we've got x minus 2. This is for part 2. And we've got 2x squared plus x minus 1 from the work we just did up here. That's x minus 2, double brackets, 2x and x. It can only be 1 and 1. So I just need to get my signs right. So it's plus 2 minus 1. So plus 1 and minus 1 here. And that's it factorised for our second mark. Okay, part B of this question is a sequence question, so you can skip ahead if you're just wanting to revise polynomials at the moment. But for the sake of completeness, I'll finish the whole question. So it says the fifth term of a sequence is given by u5 equals 2a minus 3, and it satisfies this recurrence relationship. Show that u7 is that. So we'll just need to go up to u6, then u7. So for part B, u6 from this bit here is a times u5 minus 1, the one before. A u5 minus 1. So that equals a times 2a minus 3. Take away 1. So u6 is equal to 2a squared minus 3a minus 1. And now we need to do u7. Well, u7 is going to be a times u6 minus 1. So that is a times 2a squared minus 3a minus 1. Take away 1. Multiplying the brackets out, we get 2a cubed minus 3a squared minus a minus 1. And there's our u7. Okay, going on to part C of this question. For this sequence, it is known that u7 equals u5 and a limit exists. Determine the value of a. So let's do part A first. Part 1 first. u5 equals u7. So I can just write u5 again, which was 2a minus 3. So we know that 2a minus 3 on the right equals 2a cubed minus 3a squared minus a minus 1. And we need to solve this equation. So moving everything to the right, we get 2a cubed minus 3a squared minus a minus 2a is minus 3a minus 1 plus 3. 3 minus 1 is 2. So plus 2 equals 0. So we've now got a cubic to solve, so it's actually back to polynomials. 2a cubed minus 3a squared minus 3a plus 2. We've already factorised that. So taking our answer from part A minus 2, 2a minus 1, and a plus 1 equals 0. So that means that a equals 2. 2a equals 1, so a equals a half, and a equals minus 1. And we've solved that. The limit exists, calculate the limit. So this is just a pure sequence question for a limit to, if the limit exists, that implies that minus 1 is less than a is less than 1, and therefore a must equal a half because the other two ones are invalid. The limit is given by b over 1 minus a. So remember, un plus 1 was equal to aun minus 1. We now know that, so b is our last number, so it's minus 1 over 1 minus a half. That's minus 1 over a half, which is minus 2. So the limit of the sequence is minus 2. History Higher Maths 2018 Paper 2 Question 8. The wave function. Part A expressed 2 cos x minus sin x in the form k cos x minus a. Okay, quite standard question here. If we're to express it as k cos x minus a, I expand k cos x minus a and then equate both sides. So for part A, I can write 2 cos x minus sin x equals, start of exam paper, k cos x minus a is k cos x cos a. And then it becomes plus k sine x sine a. Because k's times everything. You could have like k bracket that, then expand the bracket. It's quite easy to do it that way. So looking at what is in front of our cos x, on this side in front of cos x and attached to it is k cos a, and on this side it's just 2. So I can immediately write k cos a equals 2. And similarly, looking at our other sine x, that's attached to k sine a, and this sine x is attached to a minus, so a minus 1. So I can immediately write k sine a equals minus 1. And now we need to just get our k's and get our a's. So to get our k's, because sine squared plus cos squared equals 1, you can just write straight away that k is the square root of 2 squared plus minus 1 squared. Just like Pythagoras. That's the square root of 2 squared is 4 plus 1 squared is 1. That's root 5. So our k is root 5, and that's a simplified third. We'll now work on getting our a. Because sine divided by cos is tan, I'll show you that here. Tan a is sine a over cos a. Tan a equals sine a is minus 1, or k sine a is minus 1, and k cos a is 2. But the k's cancel when you divide them, so you just get minus a half. So I need to do the inverse tan of a half. So the inverse tan of a half is 26.6 degrees. And then using our cast diagram to see which quadrant our angle is in. Now remember with this one, although it's tan A is negative, so you're tempted just to say T, S and C, it's to do with what sine and cos were. So sine was negative and cos was positive, so we tick for cos and sine. So when cos is positive, it's these two, and when sine is negative, it is these two, so it's in the fourth quadrant. So that means that our A degrees is equal to 360 minus 26.6. So A is equal to 333.4 degrees. And now we just write our answer as k cos x minus a. So our answer is root 5 cos x minus 333.4 degrees. And we're done there for part A. Part B, hence will always find the maximum and minimum value of 6 cos x minus 3 sin x, and then find the value for which it occurs between 0 and 360. Well, if you look at this one here, that times 3 gives you this one here. So if I just times my answer by 3 to part B, I can find the max and minimum values. Well, just the minimum. Part B, since it is 3 lots of it, I can say we've got 6 cos x minus 3 sin x degrees is equal to simply 3 times the answer we just got, which is root 5 cos x minus 333.4 degrees, because it's a multiple. Okay, minimum value of this, well, let's look at a cos graph in general. A normal cos graph goes between 1 and minus 1. This is the amplitude, so this one goes between 3 root 5 and minus 3 root 5. So straight away we can say that our minimum value is minus 3 root 5. So there's our first thing, and then we have to work out where it occurs. So where does the minimum value normally occur? Well, usually it goes 90, 180, 270, 360. But this here, x minus 333.4, means it's been shifted to the right by 333.4. Now, if I shift from 180 to the right, it will take me outward for 360. So I need to find the next value. So you could just go up and then take away 360. Or if you imagine the cos graph continuing behind me, that would be minus 180. So I can just do that shifted to the right. I would get 333.4 minus 180. If I do that sum, I get 153.4. So it occurs at 153.4 degrees, and we're done there. SQA High Maths 2018, Paper 2, Question 9 on differentiation and optimization. A sector with a particular fixed radius x and the perimeter P of the sector is given by this. Find the minimum value of P. So stationary points occur when you differentiate and make it equal to 0. So starting with P of, that's a function of x, that's 2x plus 128 x to the minus 1. So P dash x is simply 2 minus 128x to the minus 2, or it's equal to 2 minus 128 over x squared. So stationary points when P dash x equals 0. So that gives me 2 minus 128 over x squared equals 0. So we need to solve that equation, so getting rid of the denominator. So we have got, imagine that's over 1. Common denominator is x squared. You get 2x squared on the top minus 128 equals 0. So then we can just say that that's like over 1, 0 times x squared 0, and this times 1. So we get 2x squared minus 128 equals 0. Simply solve that one. We'll just say 2x squared is 128. And x squared then is half of that, which is 64. So x is the square root of 64. So x would equal 8 or minus 8, but x is greater than 0, so we can just disregard that one. So we've got x equal to 8. We now need to do a nature table to make sure that it's a max or a min. So looking at our nature table, we've got x, we're going along A8 and along, and then we're looking at P dash x. So a reminder of P dash x, it was 2 minus 128 over x squared. Now obviously you can't pick 0 because you divide by 0, so any other number, 1 maybe, and 10. If I put 1 into this, I get P of 1, P dash of 1 even, is equal to 2 minus 128. Well, that's clearly negative. That's 0, and then if I put P dash 10, that's 2 minus 128 over 100. Well, that's 2 minus 1.28, which is positive. So our shape is down, along, and up. And therefore, x equal to 8 is a min turning point. We have to find the minimum value of P. So remember, P of x was equal to 2x plus 128 over x. So at 8, that gives me 2 times 8 plus 128 over 8. That's 16 plus 1, and that gives me 4. 8 5 is 40, 6 is 48, which is 32. Well done here. Okay, we're discovering SQA Higher Maths 2018, Paper 2, Question 10. The equation m squared plus m minus 3x plus m equals 0 has two real and distinct roots. Determine the range of values for m. So, two real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is the number in front of x squared, which is 1. Our b is the number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared minus 6m plus 9. And then 4 times 1 is 4 times m. So minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. Solving exponential equations. SQA Higher Maths 2018, Paper 2, Question 11. A supermarket has been investigating how long customers have to wait at the checkout. During any half-hour period, the percentage of customers who wait less than t minutes can be modelled by this equation. P equals 100 times 1 minus e to the kt. Part A. If 50% wait less than 3 minutes, determine k. So I've got two values that I can just substitute in. So for part A, P equals 100, 1 minus e to the kt. So 50 is our percentage, equals 100 times 1 minus e to the power of 3k, because t is 3. Multiplying the bracket out, we get 100 minus 100 e to the 3k. So we can take the 100 over. 50 minus 100 is minus 50, equals minus 100 e to the minus 3k. Dividing through by minus 100, minus 50 over minus 100 equals e to the 3k. Well, that's a half, so that's 0.5 equals e to the 3k. You could have actually divided by 100 at this point here to get the half, worked it from there, but you get the same answer. Take the log of both sides. Natural log of 0.5 equals the natural log of e to the 3k. So the natural log of 0.5 equals 3k times the natural log of e. So that means that log of 0.5 equals 3k. So k is the log of 0.5 over 3. And we can work that out as a value in our calculator. You get minus 0.231. And we're done there. Part B says calculate the percentage of customers who wait 5 minutes or longer. So T is just 5. P is 100, 1 minus e to the minus 0.231 T, because K is minus 0.231. So when T is 5 minutes, P equals 100 times 1 minus e to the minus 0.231 times 5. And then we just need to work that out. If you do that in a calculator, you'll get 68.5. So it's 68.5%. Wait for less than 5 minutes. Because remember, this formula is for the number of percentage of customers that wait for less than a specific time. So that means that for those who wait 5 minutes or longer, which is what the question is, I just do 100 minus 68.5, which is 31.5%. Wait for 5 minutes or more. And we're done there.
SQA Higher Maths 2018, Paper 2, Question 12. Circle 1 has the equation x minus 13 squared plus y plus 14 squared equals 100. And circle 2 has this equation. Write down the coordinates of the centre of circle C1. Well, that's nice and easy. C1 centre equals 13 minus 4. Part 2 says the centre C1 lies on the circumference of C2, show that C is minus 455. So we've got our equation x squared plus y squared plus 14x minus 22y plus c equals 0. But we know that this centre lies on it. So if it lies on it, it means if I sub in 13 and minus 4 for x and y, that has to equal 0. Otherwise, it wouldn't lie on it. So we can just do that. So we get 13 squared plus minus 4 squared plus 14 times 13 minus 22 times minus 4 plus c equals 0. Bit of maths to do, but this was a calculator paper, so you just get your calculator out and work it out. you get 169 plus 16 plus 182 plus 88 plus c equals 0. So then adding up all the numbers, you get 455 plus c equals 0, and therefore c is negative 455 as required. Okay, part B says the line joining the centres of the circles intersects C1 at point P. Determine the ratio in which P divides the line joining the centres of the circle, and then find the coordinates of P. So the radius of C1 we already know is equal to 10. And we can work out the radius of our second circle by using the formula at the start of the exam paper, but remember it is the square root of g squared plus f squared, so g is going to be 7 and f is minus 11 minus c, which is in this case 455, so plus c. So that gives us the square root of 625, just put it in a calculator, which is 25. So we've got our two radiuses. We know this radius here from C1 to P is 10. We know the radius from here all the way over to here is 25, so that must be 15, because 15 and 10 make 25. So the ratio is dividing, P is dividing the line, is simply 15 to 10, which we can simplify to 3 to 2. And we're done there. Part 2, hence or otherwise determine the coordinates of P. So the centre of our first circle is minus 7, 11. And then drawing another line. I'll draw a right angle triangle here. We know that the distance here must be 13 minus 7, which is 20. And we know that the distance up the side is 11 minus 4, which is 15. And P is 3/5 of the way along. So I just need to do 3/5 of 15. Nine and 3/5 of 20, which is 12. Minus 7 add 12 is 5. For our y part, we're starting up at 11 and we're going down 9. 11 minus 9 is 2. So we get 5, 2. And we're done there. P is the centre of a third circle, C3. C2 touches C3 internally. Determine the equation of C3. So it's best to probably draw a picture for this one. So there's our picture. We've got our original picture, and then we've got this new circle, and it says that C2 touches C3 internally. So it's touching it at one point inside the circle. And we have to determine the equation of C3. Remember, P is the centre of this big, massive circle. Okay. So our centre, we already know, is 5, 2. And we need to work out our radius. But we already know some information from what we've already worked out previously. We know that the radius of this big circle here is 25. And we know that the distance between here and here was 15, because it was 10 over here as well. 10 and 15 make 25. So if we know that this is 25, and from here to here is 15, then the radius of our new circle is 25 plus 15, which is equal to 40. So now we've got everything we need. We can just write down our equation of our circle, x minus 5 squared plus y minus 2 squared equals 40 squared. Working out 40 squared, you get x minus 5 squared plus y minus 2 squared equals 1600. And we're done.